November 2022, the examiner mentioned that this particular question was a challenge overall, with Part B causing problems in particular. So the question is why? What was it about this problem that made it such a challenge? What it boils down to is the fact that ultimately this covers a part of complex numbers that's often neglected and forgotten about. A part of complex numbers which can lose you marks unnecessarily if you don't know what you're doing. To start off, we're given two complex numbers defined by u equals 2e pi over 4 I and w equals 3e pi over 3i. What's very important to notice here is that both u and w are in polar form instead of Cartesian form. With this context in mind, we're given the actual substance of the question. That is that part A wants us to find u squared over w in the form rei theta. Well, we know that we're already in the form rei theta, so we can check that box firstly. We have w, we have u, but we don't have u squared. So let's go ahead and get that. Great. So now we have both u squared and w. But now we have to divide them. What answer do we get here? Pause the video and give it a try. As you can see from here, we get a final answer of 4 over 3 e to the pi over 6 I, which when cross-referenced with the form rei theta means that r equals 4 over 3 and theta is equal to pi over 6. Now, part B really makes you think. It says to state the least positive integer n, such that the imaginary element of w to the power of n equals 0, and the real element of w to the power of n is greater than 0. If you're anything like me, upon reading that, you go, what the does that mean? But when you break it down, it becomes much easier. Let's break down what w to the power of n actually is. All it is just 3e to the power of pi over 3i to the power of n, which becomes 3 to the n times e to the power of n pi over 3i. So we need to find the least value for n, such that e to the power of n pi over 3 times I equals 0, and yet we know that 3 to the n will always be bigger than 0.
What just happened?
The problem here is that e to the power of anything can't ever equal 0. So this seems like a trick question. But is it? You see, at the moment we have the complex number in exponential form. What if there was a form we could convert this to that doesn't require e? Can you guess it? Pause the video and try to figure it out. The solution here is to convert this into polar form, which will give us 3 to the n times cos n pi over 3 plus I sine n pi over 3. For the imaginary part to equal 0 now, we have to ask, when does I sine n pi over 3 equal 0. And that is when sine of n pi over 3 equals 0. So if we let x equal n pi over 3 and set sine x equal to 0, therefore x must equal a multiple of pi according to our trig rules. And we get a multiple of pi by making n a multiple of 3. The lowest multiple of 3 is obviously 3, but then we get cos pi when we plug everything in, which gives us -1, violating the rule given to us for real numbers, because it's less than 0. The next multiple of 3 is 6, and when we plug this in we get cos 2 pi, which gives us 1, which satisfies the condition. So therefore, n must be 6.